Welcome, Math 20-1s. We're going to do some solving quadratic equations today by factoring. Excellent. Here we go. A quadratic equation is an equation in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers. A can never equal 0. Why would they have that restriction? Well, if a is 0, we've got no x squared term. So we get a linear equation rather than a quadratic equation. When solving a quadratic equation, ax squared plus bx plus c equals 0, we are interested only in the values of x that make that expression equal to 0. We call these values the solutions or roots of the equation. To solve a quadratic equation by factoring, we're going to apply the zero product property, and that states if the product of two real numbers is 0, then one or both of the numbers must be 0. Thus, if a times b equals 0, a can equal 0, b can equal 0, or a and b can both equal 0. We're going to use this property every time we solve a quadratic equation using factoring. Since you're asked to solve x squared minus 10x plus 16 equals 0. We notice the left side of this equation is a simple trinomial. We're going to factor that using sum product. What two numbers add to negative 10 multiplied to 16? We're going to use those two numbers to factor the left side of this equation. Keep the right side equal to 0. So x minus 8 times x minus 2 equals 0. We're now going to use the zero product property. A times b equals 0. X minus 8 times x minus 2 equals 0. The property says if this is true, then a can equal 0 or b can equal 0. Therefore, x minus 8 can equal 0 or x minus 2 can equal 0. Now we have two very simple equations to solve. X minus 8 equals 0, that's a very simple equation to solve. X equals 8. Here, x minus 2 is 0, therefore x is 2. The solutions or roots of this quadratic equation are x equals 8 or x equals 2. If we try this one, it's a little more complex because the left side of this equation is a complex trinomial. We've learned how to factor these. You can use any method you want. I'm going to show you how to use the inspection method again. The factors of 3 are 1 and 3. The factors of 14 are 1, 14, 2, and 7. I notice that 3 times 7 is 21, 1 times 2 is 2. I notice that 21 minus 2 is 19, so I want my 2 to be negative. And I'm going to use these numbers, 1 and 3 in the front of the bracket, negative 2 and 7 in the back of the bracket. I'm going to use those to factor the left side. So my factors should be 3x minus 2 times x plus 7 equals 0. You could use a method of decomposition to factor this trinomial. Whatever it takes, your job now is to be able to factor this left side of this equation. Once we're done factoring, now we're going to use our zero product property. Set each factor equal to 0. So 3x minus 2 can equal 0, or x plus 7 can equal 0. And from this point, we solve these two equations. The left equation, we're going to add 2 and then divide by 3. So x can equal 2/3. The right equation here, we could minus 7 from both sides, so x would equal negative 7. Let's try one more. X squared plus 8x equals 0. I like to call this a baby quadratic. It's only got two terms on the left side. Not really a trinomial, obviously, but how do we factor that? We factor that using common factoring. So the common factor of these two terms is an x. We're left with x times x plus 8. Same rule. Zero product property. Let each factor equal 0. Solve these simple equations. Well, one of these is already solved. X equals 0. Beautiful. The other one is x equals negative 8. A couple more to try. Let's try 3x squared minus 18x equals 81. Well, right now I can't factor this. The left side's a baby quadratic, the right side's a whole number other than 0. Step 1 should always be simplify and set the equation equal to 0. So this equation is not equal to 0. We must let it equal 0 before we solve by factoring. So I'm going to minus 81 from both sides of this equation, come up with 3x squared minus 18x minus 81 equals 0. Now we can factor the left side of this equation. Looks like a complex trinomial, but I also notice that every term is divisible by 3. So I'm going to take out a common factor of 3. That leaves me 3 times x squared minus 6x minus 27. And now I've got a simple trinomial inside the brackets. With the numbers, add the negative 6, multiply the negative 27, and factor that accordingly. So I get 3 times x minus 9 times x plus 3. At this point, I could divide both sides by 3, or I can just look at the variable factors and set each of those equal to 0 using my zero product property. So x minus 9 would equal 0, x plus 3 would equal 0. And solve those very simple equations. X would equal 9, x would equal negative 3. We've solved the quadratic equation given to us. If I look at example B here, step 1 would be to expand out the brackets on the right side of this equation. We can't simplify the left side at all. So we get 3x squared add 6 equals x squared plus 13x. I now want to set the equation equal to 0, just like we did last example. So I'm going to move x squared to this side. I'm going to minus 13x. So I get 3x squared minus 1x squared is 2x squared minus a 13x, and I still have the plus 6 on the left side. So 2x squared minus 13x add 6 equals 0. Once I've set the equation equal to 0, I can now factor the left side of this equation. Again, you can use decomposition, it'll work. Factor this perfectly. You can use inspection. Bottom line is you're now expected to be able to factor the left side of this equation as 2x minus 1 times x minus 6. Once we're done factoring, we use our zero product property, set each factor equal to 0. So 2x minus 1 can equal 0, or x minus 6 can equal 0. And we solve these simple equations. This one we're going to add 1 divided by 2. Here we're going to add 6. So x could equal 1/2, or x could equal 6. Lovely. A couple more difficult ones. This example, I've got a radical equation. In order to solve a radical equation, I want to eliminate everything from the same side of the equation as the radical. So I want to move the 4 to the other side and isolate my radical. So I'm going to minus 4 from both sides of this equation. I get square root 6 minus x will equal x minus 4. Now that I've isolated my radical, I can now square both sides of this equation. The opposite of square rooting is squaring, and whatever I do to one side, I must do to the other. So I square both sides of this equation, and I get 6 minus x equals, and I expand out this binomial, x squared minus 8x plus 16. Now we're at the stage we were in the last slide. We're now going to set this equation equal to 0. So I'm going to minus 6 over here, and I'm going to add an x. So I'm going to get x squared minus 7x plus 10 equals 0. I can now factor the left side of this equation. It's a simple trinomial. Adds to negative 7, multiplies to 10. Those are two numbers are in minus 2 and minus 5. So my factors are x minus 2 times x minus 5. And I can set each factor equal to 0 now. So x minus 5 equals 0, or x minus 2 equals 0. And again, very simple equations to solve. Add 5 to both sides, I get x equals 5. Here I add 2 to both sides, I get x equals 2. Very, very important to remember. It's always important to verify, make sure your solutions are correct, but it is super important in a radical equation because we know we can't take the square root of a negative number. We would have a restricted domain, so to say. So we want to check and make sure these are correct. Always want to make sure we verify solutions with radical equations. So check these, make sure it works. 6 minus 5 is 1. The square root of 1 is 1. 1 plus 4 is 5, and we plugged in x was 5. So we know 5 works. Substitute 2. 6 minus 2 is 4. The square root of 4 is 2. 2 plus 4 does not equal 2. Therefore, x equals 2 should not be a solution. And we should put a big X through this. That is not a correct solution. Alright, so make sure you cross x equals 2 off. The only correct solution is x equals 5. Alright. Equation B. I've got fractions here, so what I'm going to want to do is multiply every term in this equation by the lowest common denominator, and that is 4. So 4 times x squared over 2, 4 times 5x over 4, and 4 times 3. So 4 times x squared over 2 gives me 2x squared. 4 divided by 2 is 2. 4 times 5x over 4 gives me 5x, and 4 times 3 is 12. So I'm left with 2x squared minus 5x equals 12. Again, set this equation equal to 0, so I minus 12 from both sides. I've got a complex trinomial on the left side of this equation. Factor using decomposition or factor by inspection, but we factor it and we should come up with 2x plus 3 times x minus 4 equals 0. Set each factor equal to 0 and solve these simple equations. The left one I'm going to minus 3 and divide by 2. Minus 3 divide by 2. The right one I'm going to add 4. So here x equals negative 3 halves. Here x equals 4. Always a good idea to verify and make sure they work. Absolutely mandatory with a radical equation to make sure you verify. Like we said, x can't equal 2 on this one. So your assignment that we're going to work on in class the next day is given right here. Come prepared to work on that and make sure you know how to factor. Right on. Bye-bye.